Okay, so we went down to 6 on 6, and we're going to do problem number 9 first. So these first couple are says evaluate the expression without using a calculator. So what we have is the arctangent of the square root of 3 divided by 3. And just seeing what they do here without using a calculator. So actually I'm going to ask you to know both ways well, using a calculator, and the answers should be in radians, not in terms of degrees, so make sure you do that. So the way that we would do this, which I think of which way I want to talk to you about it, there are a couple of ways we could do this. Well, we could do the unit circle. And because this is positive, we know that we're in the first quadrant. It's going to be between 0 and pi over 2. Why do we know that? Well, we knew that the domain of the inverse tangent function is from negative pi over 2 to positive pi over 2. And it's positive in this region, and it's negative in that region, and 0 is the one that breaks them up. So in terms of figuring out which one of this is one of these special angles. It's either going to be pi over 6, pi over 4, pi over 3. We know it's not 0 because the inverse tangent of 0 is 0. So, and it's not pi over 2. It's not pi over 2 because that's the inverse tangent. Arctangent would be infinity. The arctangent of infinity would be pi over 2. So since it's a finite number, so it's got to be one of these 3. And if you think about the numbers, remember the numbers that you have 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Those are the values for the sine of theta at the various things. So in some ways, I hate to memorize things, but this is kind of one of those things that it's really not that hard to memorize. You've seen these enough. And they go in increasing order. So the cosine is easy because if you know the sine, you just write them backwards. So you start 0 here, and then you go back in that direction, like that. So you know it one way, you know it the other way. And then the tangent of theta is the ratio is the sine over the cosine. So you got 0 over 1, which is 0. Here you'd have 1/2 divided by square root of 3 over 2. Well, you have the same denominator, so you'd end up with 1 over the square root of 3, but we don't like square roots in the denominator, so we multiply by the square root of 3 over 3, and you get square root of square root of 3 divided by the square root of 3, so you get square root of 3 over 3. Here they're the same numbers, so that's 1. And then you get the other one, which is the square root of 3 over 1, because you have the same denominator. So you get the square root of 3, and then you have 1 divided by 0, which is infinity. So that's kind of how you generate the table. And then it's easy to look at it and see, what angle has a tangent of square root of 3 over 3? Well, you have pi over 6. Now, using your calculator, that's pretty easy. Use the inverse tangent of this. Make sure you're in radians. And so if I thought my calculator, so as long as you're in radians, so let me check mode, radians, yeah. So we do the inverse tangent, the second tangent, square root of 3 divided by 3, right parentheses. So what we get from the calculator is 0.5236. And so to get it in terms of pi, which is what we want to do, is we're going to take 0.5236, divide by pi, multiply by pi. So we take this plug that into our calculator, and we divide. So we already have 0.5236 in our calculator, so we just say answer equals, and then we divide by pi. If you don't have that on your calculator, just put in 3.14159. So we get 0.166 pi, which is pi divided by 6. As we said earlier, we have to remember these things. So that's equal to 1/6. 2.5 is equal to 1/4. 0.33 is equal to 1/3, and those give us pi over 6, pi over 4, pi over 3. Okay, so that's how 9's done. Okay, 24. We have the cosine of the arc cotangent of x. Write the expression in algebraic form. So what we're going to do is we're going to say theta is the arc cotangent. So we take what's in the parentheses, arc cotangent of x. Then we draw our triangle based on that. Right triangle. So here's our right triangle. So we're going to say this is the angle of theta. The cotangent is x, which is the same as x over 1. And the cotangent is, so the cotangent of theta is going to be equal to, well, the tangent is the opposite over adjacent, so it's going to be adjacent over opposite. So I'll make the adjacent side x and the opposite side 1. And so using the Pythagorean theorem, this is going to be x squared plus 1 squared, take the square root, that will give you the hypotenuse. So we know h is equal to this, and this is equal to O, and this is equal to A. So this is the opposite adjacent hypotenuse. So theta is the angle, whose cotangent is adjacent over hypotenuse. Okay, so now all we have to do is say what is the cosine of theta, where theta was this. Well, the cosine of theta is the adjacent over the hypotenuse. So the adjacent is x, the hypotenuse is the square root of x squared plus 1, and that is the answer. So I kind of break it up into 2 parts. And that is problem number 24. I just want to make sure that's right. And it is. Okay, we're on problem 28. So it's similar to what we just did on 24. So we had the cosine of the arc sine of x minus h over r. So this is, let's say theta is, we'll call theta this thing that's in the parentheses. So we get arc sine of x minus h over r. This is, remember, the sine of theta is equal to the opposite over the hypotenuse. So we draw a right triangle. Call this theta. So the sine is the opposite over the hypotenuse. So theta is the angle whose sine is the opposite over hypotenuse. So the opposite side is x minus h. And the hypotenuse is r. Opposite over hypotenuse, opposite over hypotenuse. So to find, we need to find this length. So we know from Pythagorean theorem that r squared, let's call this a, r squared is equal to a squared plus x minus h squared. So these two, this squared plus that squared equals that squared. And what we want to do is solve for a. So we'll say a squared is equal to x minus h squared minus r squared. So what we do is we, actually is that right? No, that's not right. Let's try it again. We'll subtract this from both sides, so we get it's equal to r squared minus x minus h squared. Now I can take the square root. So a is equal to the square root of r squared minus x minus h squared. Okay, that's my adjacent side. So let me just write that up in there. Square root of r squared minus x minus h squared. So now that we know that, now that we have all the sides of the triangle defined in terms of the variables, x is the variable, h and r are constants. So the cosine of theta is, looking down the triangle, is the adjacent over the hypotenuse. And the adjacent is the square root of r squared minus x minus h squared. That's the adjacent side. The hypotenuse is r. And that's the answer. So the cosine of theta, but theta is the arc angle whose sine is x minus h over r, is equal to the square root, same as cosine of theta, which is the square root of r squared minus x minus h quantity squared divided by r. Okay, we're up to problem 32 right now, I think. 32. So it says solve for x in the equation. So what we have is the arc tangent of 2x minus 5 is equal to 1, negative 1. So to solve these equations where you have, this is arctangent, you use the inverse properties of the tangent and the arctangent. So remember that the tangent of the arctangent of x is equal to x, and the arctangent of the tangent of x is equal to x. And basically what's saying, the tangent of the angles whose tangent is x, and the angle whose tangent is x of the tangent of x is x. Okay. So what we do is we take the tangent of both sides. So you get the tangent of the arctangent of 2x minus 5 is equal to the tangent of negative 1. And so when you do this, this becomes, because these are inverse functions, the f of g of x thing, you just get 2x minus 5. And then we get the tangent of negative 1. And this is negative 1 radians. So is that, what is that? Well, if you think about it, the tangent function looks like this. And you remember the domain of the tangent goes from negative pi over 2 to positive pi over 2. But pi is 3, approximately 3, so this is going to be like negative 1.5 something. This is going to be positive 1.5 something. So negative 1 is somewhere in here. About 2/3 of the way between 0 and pi over negative pi over 2. And you're going to see it's a negative, the number is a negative, tangent, that number is negative. Okay, let's go ahead and do all the algebra, and I'll do the plug and check in. So we get 2x is equal to 5, positive 5, because we add 5 to both sides. 5 plus the tangent of negative 1. So x is equal to 5 plus the tangent of negative 1 divided by 2. And now we just plug it into our calculator. So make sure that when you do this, if you want to do this in one spelled swoop, you're going to have to put parentheses around the top so that it groups those together. And then divide by 2. So you do a left parenthesis 5 plus the tangent of negative 1, right parenthesis, divided by 2. So that puts parentheses around the whole numerator. And I get 1.721. So x is equal to 1.721. But again, you can always check this out. So what we would do, in terms of our calculator, we would say inverse tangent of 2 times 1.721. So 2 times 1.721 minus 5. And so we get the inverse tangent of 2 times 1.721 minus 5, which is negative 1.558. So the angle whose tangent is negative 1.558, so we do the inverse tangent of that answer, negative 1.558, right parenthesis, and we get, use the wrong negative sign, not the minus sign. And I get, if you do that, you get negative 1.000, blah, blah, blah. So, is that the right answer? Yes. Okay, so we're finally actually getting to some integration, I think. Yep. 43. So we have g of x is equal to, we're getting to differentiation, not integration. G of x is equal to the arc cosine of, actually there's a 3 there, isn't there? 3 times the arc cosine of x over 2. So, you know, we have the formulas, and basically what it says is that we just do our normal thing. We're going to use the chain rule because this is not just arc cosine of x, so we're going to rewrite the original equation in terms of g of u. G of u is 3 times the arc cosine of u, and u of x is equal to x over 2. So when I plug that in there, I'll get 3 arc cosine of x over 2. So we take the derivative, g prime of u is equal to 3 times 1 divided by x to the negative 1 divided by the square root of, what the heck is it here? So if you go to page 376, this is our new complete list of integration. It says minus u prime over 1 minus u squared. So actually I'm going to, that's kind of incorporating the chain rule. So I'm going to, rather than learn something new here, we're just going to treat it as we normally did. So it'll be equal to minus 1 over 1 minus u squared. Instead of the u prime is going to come in through here. So we get u prime is equal to 1/2. Derivative of x is 1. We just have a constant 1/2. So now we do the chain rule, which says g prime of x is equal to g prime of u times u prime of x. G prime of u is, okay, we have negative 1 times 3, which is negative 3, divided by the square root of 1 minus u squared times u prime of x, which is 1/2. And finally, we plug in what u is. So we get negative 3/2. So let's put that out in front. Let's just make that a constant. Negative 3/2 times 1 divided by the square root of 1 minus u, which is x over 2 quantity squared. And let's see how far they simplify this thing. Okay, so they go a little further with this. So what we're going to do is we are going to multiply out the denominator and the square root. So what you get is you get 1 minus x squared over 4. But what we can do is we can move this 2 inside. What that does is when you move the 2 inside, you have to square it. So what we'll get, well, basically what we get, let me just, really what we have is 2 becomes the square root of 4. So I'd replace 2 with the square root of 4. And when you have two things that are square roots, you just multiply the terms together. So we take 4 times 1 and 4 times negative x squared over 4. So this ultimately becomes negative 3. We get negative 3 times 1 is negative 3. And this becomes square root of 4 minus x squared, because 4 times 1 is 4. 4 times x squared over 4, you cancel the 4's out and you get x squared. So it simplifies down to something nice. So that's your final answer right there. Okay. Okay, try to find out where my thing is here to stop. Okay, so we're going on. Number 50. So 50 is y is equal to x times the arc cosine of x minus the square root of 1 minus x squared. And you're thinking, whoa, things got complicated. What's happening here? Especially since I wrote the wrong problem down. Okay, sorry about that. That's number 51. So actually, we will wait till the next time to do the little low part here, but for right now, we just have this, which is just two separate derivatives because it's connected by the plus sign. So, we don't have to use product rule or quotient rule because it's not a product, it's just two terms. So if we wanted to find f prime of x, all I have to do is take the derivative of that, which is just 1 over the square root of 1 minus x squared. And the second one is going to be negative 1 over the square root of 1 minus x squared. And so this is positive and that's negative. The answer is actually going to be 0. The derivative is always 0. So why is that? Is that true? Is that the answer? The answer that is, well, yes. Okay. So another way of what they show in the book here is that if you take the angle whose sine, let's pick a number. So let's pick 30 degrees. Let's not use 30 degrees. Let's use pi over 6. So what is the sine of pi over 6? The sine of pi over 6 is equal to 1/2, and the cosine is equal to the square root of 3 over 2. So actually, wait a second here. Yeah, that's not good. I want to use that explanation to explain what's going on here. Well, let's see. So let's let x equal 1/2. So if you said, what is the arc sine of 1/2? The angle whose sine on 1/2 is pi over 6. And if you say, what is the arc cosine of 1/2? The angle whose sine is 1/2, cosine is 1/2 is pi over 3. So if you take pi over 6 plus pi over 3, you get pi over 6 plus 2 pi over 6, which is equal to 3 pi over 6, which is equal to pi over 2. And it turns out it doesn't matter what number you pick. So let's just pick some weird number here, 0.372. X equal that. Well, if you use your calculator, the angle whose sine is equal to 0.372 is, and I'm going to just leave these in decimal form until I convert it finally. So if we take the inverse sine, arc sine of 0.372, we get, in radians, we get 0.38116. And if we do the arc cosine of the same number, so we do the arc cosine of 0.372, we get 1.18963. So if we add those two together, 3, 8, 1, 6, 2, 7, 2, 5, I get 1.5708, and pi over 2 is equal to, if you take pi and divide by 2, you get 1.5708. So this is pi over 2. So it doesn't matter what the value of x is, you always get pi over 2 for this answer. And when you do the derivatives, you always get 0 because this doesn't change. If this is a constant, always a constant, then the derivative of a constant is 0. And it shows out, we could do this and take the derivative of a constant, say it's 0, or we can take the derivative of each one of these separately and add them together, and then they cancel out and go to 0. Okay, what are we on? 57. Okay, so here's the advertised one. I said it gets kind of crazy here. And the reason we do this is because when we take the derivative of this first one, we're going to end up being able to cancel out some terms associated with the second expression. So if we did it wrong, it won't do that. So you have one part that's a arc sine and one part that's this product rule of a algebraic nature. So what will turn out is when we take the derivative here, when we take the derivative of this, we'll get two terms because it's a product. One of those terms will cancel out with that, and we'll just end up with one term. So it looks complicated, but it actually comes out to be something that's simplified. So what we're going to do is, let's do this first part. We'll do each one separately, and then we'll put them together. So let's call f of x the first part. So what do we have to do to do this? Well, because the argument of sine, arc sine, is not just x, we're going to use the chain rule. So we're going to say f of u. So f of u is equal to 8 times the arc sine of u. And u of x is equal to x divided by 4. So the chain rule always says we take the derivatives of each one of these, the f of u and the u of x. So here we're going to get 8 divided by the square root of 1 minus u squared. So the 8's from the constant. We get 1 over the square root of 1 minus u squared. And then we take the derivative of u, which is just 1/4, because the derivative of x is 1. Okay, so then we use the chain rule that says f prime of x is equal to f prime of u times u prime of x. So we substitute in. F prime of u is 8 divided by the square root of 1 minus u squared times 1/4. And so we get f prime of x. We substitute u back in. So we get the square root of 1 minus u, which is x over 4 squared times 1/4. So let's simplify this a little bit, just like we did in the previous problem. So we're going to have 2 divided by square root of, we're going to multiply this thing out, so you get 1 minus x squared over 16. So x squared is x squared, and 4 squared is 16. Now, we want to get this so that this looks something like that. So what we would do is we would multiply by 4 here, and we'd multiply by 4 there. So we're multiplying by 1. So we're going to get 8 in the numerator. And in the denominator, remember 4 is the square root of 16. So what we'll get is we'll get the square root of 16 times 1, which is 16, and square root of 16, well, 16 is coming inside because 4 squared is 16. So this becomes 16 minus x squared. Times 2 is 8. This is the square root of 16, so we multiply the square roots. So we take 16 times 1 and 16 times 1 minus negative x squared over 16, and 16 is canceled out. You just get that. So that is f prime of x. The second part is, we'll call this g of x is equal to x times the square root. I'm going to rewrite this as a fractional exponent. So that's the 1/2 divided by 2. So that's g of x. It might look like a quotient, but it's really not a quotient. It's 1/2 times the quantity x times x, 16 minus x squared. So the 1/2 power. So what it is a product rule problem. So let's make up some variables here. Let's use j and k, g of x. So we're going to say g of x is equal to 1/2 times j of x times k of x. I just chose those because I couldn't use f and g because I've already used those. So in this case, j of x, put that over a little bit to the left. J of x is equal to x. K of x is equal to the quantity 16 minus x squared to the 1/2 power. This one's easy. J prime of x is equal to 1. K prime of x is a little more difficult. I have to use the chain rule here, but we're going to do it in our head instead of writing it all out because it just takes too long. Hopefully you're getting to the point where you can do this. So this is the term that we're going to take the derivative of and multiply by the result. So you take the exponent, 1/2, you multiply by the same expression, you reduce the exponent by 1, so 1/2 minus 1 is negative 1/2. So you think that's done, but you have to take the derivative of what's inside here, and that is going to be negative, this goes to 0, so derivative of 16 is 0, so you get negative 2x. So the derivative of 16 minus x squared is negative 2x. See, the 2's cancel out. So k prime of x is equal to, well, let's move this to the denominator. So we're going to have negative x divided by the square root of 16 minus x squared. So what I did is I moved this to the denominator, and then I changed it back into a square root sign. So now let's plug in. So g of x is 1/2 times, well, actually g prime of x. I have to take the derivative. So it's going to be, so what we have here, g prime of x is equal to 1/2 times j of x times 8k prime of x plus j prime of x times k of x. So that's the product rule for these two terms. So let's just plug them in there. So we have j, which is x, times k prime of x, which is negative x divided by the square root of 16 minus x squared. So that's this times that, plus j prime, which is 1, times k of x, which is, I'm just going to put in here square root again, 16 minus x squared. So that's this term. So that's g prime of x. So let's go back. Now we need to put everything together. So what we're going to do is we have to add, what we're doing is we're going to take f prime of x plus g prime of x. That'll give us the final derivative because we started off with the sum of these two things. So let me just copy what we have. We have this. So let me take that, group it together, copy it, put it on a new page here. So there's f prime of x, a bit smaller. And then we have g prime of x. We already have that up there. So, and hopefully what we have is something that's going to work out here. What did I do wrong here? No, it's going to work out. Okay. You actually have to find a common denominator here, so let's move this stuff down a little bit. So, what do we get here? Well, I want to combine these two. So I'm going to multiply this by the square root. We're going to multiply and divide by the square root of 16 minus x squared. So what we'll get is we'll get 1/2. And here we get x squared, negative x squared, divided by the square root of 16 minus x squared times the square root of 16 minus x squared divided by the square root of 16 minus x squared. And then we get the square root of 16 minus x squared times the square root of 16 minus x squared divided by the square root of 16 minus x squared. And so this numerator becomes, you multiply these together, you get 16 minus x squared. So let's see what happens here. So the first one, we'll get negative x squared square root of 16 minus x squared divided by 16 minus x squared, because you take this times that, and you just get the expression. And the second term is 16 minus x squared divided by the square root of 16. I didn't want to do that part. I only want to do it on the second part. That's my problem. Still, I was doing wrong. Okay, so let's get 1/2, and what we'll get is minus x squared divided by the square root of 16 minus x squared. And we have the same denominator here, so I'm just going to pull this out because we now have the same denominator. And the second term, when you multiply 16 minus x squared times 16 minus x squared, you will get you get 16 minus x squared. And so finally, we combine these two terms. So you get negative 2x squared divided by 2 from here, divided by the square root of 16 minus x squared. That's that one. And the second term becomes this part. So we're going to take the 16 divided by 2 times 1 over the square root of 16 minus x squared. That's 8. So when we now put these together, you'll have f prime of x, which is 8 divided by the square root of 16 minus x squared. And you're going to subtract off this. If you go back, we're subtracting that. Okay, so we're going to subtract that. So we subtract what we have here. These two cancel out. So we're going to subtract negative x squared divided by the square root of 16 minus x squared. And then we have plus 8 divided by the square root of 16 minus x squared. Okay, so we have 8. This term we subtracted. So these two cancel out. You have negative times negative is a positive, and so you get x squared divided by the square root of 16 minus x squared. And that should be the answer. What was that, 57? Look at 57. X squared over square root of 16 minus x squared. Okay, so I did it right. So even I get lost sometimes. Let's kind of review what we did here. Original expression. I broke it up into 2 parts. I have an f of x, which is this part. I have a g of x, which is this part. So I take these, do these separately, and then combine them. So the derivative of this expression uses a chain rule, where this is u, and you come up with, when you do all that derivative stuff, you come up with this, 8 divided by the square root of 16 minus x squared. So that's this would be the first part, this derivative of this part. Now we take the derivative of the second part, which involves using the product rule, because we have this times that. This is just a constant, so I brought that outside. We changed the square root into the fractional exponent. So the product rule says you take the original function, break it up into 2 parts. This was j of x, this was k of x. J of x, k of x. Take the derivatives of each one. You get 1. We use the chain rule here to get this, negative x over the square root of 16 minus x squared. So then we cross multiply. So we have the 1/2 f of x times g prime of x plus f prime of x times, well, in this case it's j and k, but it's this times that plus that times that. Then what I did is I multiplied the second term by the square root of 16 minus x squared in the numerator and the denominator to get a common denominator. So this is the common denominator. First term is negative x squared. The second term is this times that, which is 16 minus x squared, because it's the same term. So you get 16 minus x squared. So we take this from the second term, we combine it with this, the first term, and you get negative 2x squared divided by 2 times the square root of 16 minus x squared. Then you have the constant left over. So you have 16 divided by 2 divided by this square root of 16 minus x squared. So that's 8. So that's g prime of x. So the total derivative is f prime of x plus g prime of x. F prime of x we have previously there. And so then we just plug it in. So this is f prime of x. This is g prime of x. We subtracted. Actually, we subtracted it because of the way I defined it. And these 2 terms cancel out, and you ended up with one final expression. Okay, that was the last one was easy. Okay, so we have 2 problems left, and the first one is one of these tangent line things you've been doing forever. So the function is y equals 1/2 the arc cosine of x, and you can see what the arc cosine function looks like. You know, it's has limited range and domain because of the fact that the original function of cosine, to make it 1-to-1, we have to limit the domain. So it's the usual procedure. We take the derivative, evaluate the derivative at the x value, which in this case is negative the square root of 2 over 2. Get that value for the derivative, and you use the point sum form of the linear equation. So, and this is pretty easy because it's just the arc cosine of x. So all the answer is it's going to be negative 1 over the square root of 1 minus x squared. So y prime at is square root of 2 over 2, which is the x value. Actually negative square root of 2 over 2. So we'll plug that into the equation. So you get 1, negative 1, I'll factor out the negative. So you get negative 1/2 times 1 over square root of 1 minus the quantity, negative the square root of 2 over 2 squared. So all I'm doing is taking my mathematical expression for the derivative, plugging in the x value that's given in the problem. So we get negative 1/2 times 1 divided by the square root of 1 minus. Okay, well, since this is negative, it's going to, when you square it, it's going to become positive. And when we square it, we get 2 in the numerator and 4 in the denominator. Square root of 2 squared is 2. 2 squared is 4. So that's a half. So we get negative 1/2 times 1 over square root of 1/2. Because it's 2/4 is a half. 1 minus a half is a half. So what do we get here? We can just plug the numbers in, come up with a decimal. But let's see what we have. So you have 1 divided by 1 divided by the square root of 2. So what I did is I took the square root of 1, which is 1, and I took the square root of 2, which is the square root of 2. Okay. Now, how do we clean this up? Well, this 1 in the numerator we can define as 1 over 1. So what we do is, instead of dividing by this number, we multiply by its reciprocal. In the numerator we had 1 over 1, so it's just 1 anyway. So we take the reciprocal of that. So we get negative the square root of 2 over 2. So that's our slope. Our slope at negative the square root of 2 over 2 is negative the square root of 2 over 2. Now that we have the slope, we know that m, we'll call m the slope, is negative square root of 2 over 2, which makes sense if you look at the figure on problem 62. It is negative because it's decreasing as x gets larger. X1 is equal to negative the square root of 2 over 2. Y1 is given as 3 pi over 8, which we could calculate. If we wanted to, we could just plug in this, and what you'd find out is the angle of its cosine is negative the square root of 2 over 2 is what is it? It's going to be equal to pi over 4. Negative pi over 4. Is that right? No, it's actually going to be positive pi over 4. So anyway, you would get this answer if you plug that into here. Yeah, so let's just do it to prove it. So you take 1/2 times the arc cosine of negative the square root of 2 over 2. So negative the square root of 2 divided by 2. This is error. Okay. So why am I getting that wrong? What's going on here? Oh, because I used the, I always forget about that. I gotta use the. Okay, let's try it again. 0.5 times the inverse cosine of negative, not minus. It's not super duper calculators. So I get 1.178. And if you take 3 times pi and divide by 8, you get 1.178. So you do get the right answer. Okay. But our equation for the line is y minus y1 is equal to m times x minus x1. So we have y minus y1, which is 3 pi over 8, is equal to m, which is negative the square root of 2 over 2 times x minus x1, which is negative the square root of 2 over 2. So we get y is equal to, if we multiply that out, the x term is just negative the square root of 2 over 2 times x. And then we have the constant term. So you got a negative times a negative is positive, but then you multiply by a negative. So let's just put a plus sign here and group them together. So you have negative, when you multiply the square root of 2 times the square root of 2 over 2, you get 1/2. So this times that is 1/2, and it's going to be negative 1/2. And then we add this to both sides, so you have plus 3 pi over 8. And so the last thing I'm going to do is just change the order of the two terms here. So just so I have the positive term first. So anyway, that's the equation of the slope of the tangent line. So what we're going to do is we're going to prove this. But I need to write these equations down. So we'll plot the original function, which is the arc cosine. And then we will plot the line. So the original line was 1/2 the arc cosine of x. The slope of the equation for the tangent line is negative 1/2 negative square root of 2 over 2 times x plus 3 pi over 8 minus 1/2. Okay, so let's go to the graphing program. So it always amazes me that this actually works out. Hopefully I did it right, so it did work out. Okay, here we go, graphing program. Okay, so the two functions I'm going to put in here are, and the question is, what is the arc cosine? So you go to help, and you look down through this list, and so it's a cosine, a sine. So that's the so the first is going to be 1/2 times the a cosine of x. So that's the arc cosine. Let's just graph that. Let me see what that looks like. Okay, so there it is. Looks like the arc cosine, but it's shrunk. Let's go back and just do the arc cosine. So you can see there, that's the arc cosine. So if you multiply by 1/2, then it gets shrunk halfway in the y direction. Okay, now here's the moment of truth. Negative the square root of 2 divided by 2 times x plus quantity 3 times pi divided by 8 minus 1/2. And hopefully I did that right. Oh, I didn't like that. Okay. Maybe I don't put the parentheses in pi. Let's try that. So there it is. This is x equals negative the square root of 2 over 2. And let's just zoom in a little bit. So right here is, this is the arc, 1/2 the arc cosine of x. This is the equation for the tangent line. And there it is. Look at that. Isn't that amazing? Okay, we're going to do problem number 72 next, which is where we're finding extrema, relative extrema. So the other thing we use derivatives for is to find local extrema, which means that we take the derivative set equal to 0, solve for the values of x. Work out. Okay, so 72 is f of x is equal to the arc sine of x minus 2x. And of course, x has to be between -1 and +1 because that is the range of the domain of the domain of this, which will end up being apparent when we do the integrations, I mean the differentiation. So to find the extreme, we had to find the critical numbers. To find the critical numbers, we had to take the derivative. And so the derivative of the arc sine is going to be 1 divided by the square root of 1 minus x squared. And the derivative of 2x is 2. So that's the derivative. Then we set that equal to 0. So I'm going to say that in this particular case, because we're looking for extrema, we're going to set that equal to 0. So we're going to have 1 divided by the square root of 1 minus x squared minus 2 is equal to 0. So how do we solve for x? Well, what we'll do is we'll add 2 to both sides. So the 2 disappears from there. And then we multiply both sides by the square root of 1 minus x squared. So we get 1 is equal to 2 times the square root of 1 minus x squared. And let's divide by 2. So we'll get the square root of 1 minus x squared is equal to 1/2. Square both sides, so we get 1 minus x squared is equal to 1/4. 1/2 squared is 1/4 because 1 squared is 1, 2 squared is 4. And we're going to end up with the quadratic equation. So let's see what we're going to do. We're going to, let's add. So we're going to get set it equal to 0 and then use, well actually we don't have to because there's no middle term. So if we subtract 1/4 from both sides, we'll get 0 here and we'll get 3/4 there. So we get 3/4 minus x squared is equal to 0, where x squared is equal to 3/4. And then if we take the square roots, x squared is equal to plus or minus the square root of 3/4, which is plus or minus the square root of 3 over 2. So that's the value of x. Those 2 values of x. Now, are those within our limit of from -1 to +1? Yes, because the square root of 3, of course, is going to be less than the square root of 4 is 2. So the square root of 3 is less than 2. So it's a fraction. So it's a number between 0 and 1. So that's the location of the relative extrema. The actual extrema are. So it could be a maximum or minimum. We don't know. So how would we do that? Well, we could take the second derivative here and look at the second derivative test. So let's do that. So since the first derivative was equal to 1 divided by the square root of 1 minus x squared plus 2, so the second derivative, well, that goes to 0. This is the same as 1 minus x squared to the minus 1/2 power. This is to the 1/2 power, and then I move it to the numerator. So when I take the derivative, I get negative 1/2 times 1 minus x squared to the negative 3/2 power. And then I use the chain rule, so I have to multiply by the derivative of what's in here, which is going to be negative 2x. So the 2's cancel out, the negatives cancel out, and I end up with x divided by 1 minus x squared to the 3/2 power when I move that to the denominator. So that becomes positive 3/2 power. So the question is, what is the sign? So we don't really need to know what the value is, but what is the sign at negative the square root of 3 over 2? F double prime there. So you'll get negative the square root of 3 over 2 here, and in the denominator you'll get 1 minus the square root of 3 over 2, negative 3 over 2 squared to the 3/2 power. So obviously the numerator is negative. The denominator is going to be positive because this, when you square this, you'll get 3/4. Positive 3/4 is subtracted, and you'll get So the denominator is going to be 1 minus 3/4 to the 3/2 power. This is positive, so this is positive. So you get negative divided by positive, and therefore the sign is going to be negative. So negative means concave down, which means a maximum. So if we look at the other case, which is the other solution for the first derivative, when x equals plus the square root of 3 over 2, how does it change? Well, the numerator, so if we looked at f double prime of positive the square root of 3 over 2, you're going to get, the numerator is going to be positive the square root of 3 over 2, so that's positive. And the denominator is still going to be positive, because when you square this, you're going to get 3/4, and you get 1 minus 3/4, which is a fourth. So this is going to be, the denominator is positive, the numerator is positive, therefore the second derivative is positive. Positive means concave up means minimum. So we're going to have the minimum at x equals the square root of 3 over 2. We're going to have a maximum at negative the square root of 3 over 2. Okay, so let's prove that. We're going to plot the function, which was arc sine of x minus 2x. Okay, so we'll minimize that. Let's try it again. Okay, so there we are. You can't see it yet, but I'll show it to you in just a second. Here. Okay, so there's the graphing program. And what we want to do is we want to plot that function. And actually, we never did calculate what the maximum was, so let's go back. We calculated where the maximums were, where the extrema were, but we didn't calculate what the actual extrema were, the values. So let's do that. Okay, so here we are again. So all we have to do is evaluate the function at the two values. So f of negative the square root of 3 over 2 is, it's going to be the arc sine of negative the square root of 3 over 2 minus 2 times negative the square root of 3 over 2. Well, the angle whose sine is negative the square root of 3 over 2 is negative pi over 3. Okay, you could plug this into your, you could do this in your calculator if you just do the arc sine of negative the square root. So let's do our calculator too. So you do the inverse sine of negative square root of 3 divided by 2. And I get negative 1.047. So this is the calculator version. Negative 1.047. Which if you take pi and divide by 3, you get 1.047. So these are the same thing. Okay, and the second part is, you can see the 2's cancel out. So you just get positive plus the square root of 3. And the square root of 3 is plus 1.732. So this would be 1.732 minus 1.047, which is 0.685. So that's the function at one of the critical numbers. And then the second critical number is the square root of 3 over 2. So what we get now is the angle whose sine is the square root of 3 over 2 is positive pi over 3. And then we get negative 2 times positive the square root of 3 over 2. And so the only thing that happens is it becomes negative 0.685. So this is obviously a maximum. And this is a minimum, which agrees with what we just did here. So everything's wonderful so far. And now we're going to go to the graphing program and look at this. Okay, so I'm going to plot is the arc sine of x minus 2 times x. So there it is. That's the function. Let's zoom in a little bit. And so what's this value? It is x is equal to negative 0.88. What did I get? I got the square root of 3 over 2, which is, okay, so what is the square root of 3 over 2? Square root of 3 divided by 2 is negative 0.866. So if I really zoom in on this thing, and I look right there, you see it's negative 0.866, basically. Okay, so let's go back. And what's the value? What's the x value? It's 0.68. How does that compare with I had 0.685? Okay, so that works out good. And likewise, we have a minimum here at positive the square root of 3 over 2, and the y value is negative 0.68, something or other. And you notice that the function is only defined between negative 1 and positive 1. That's the domain, because the domain of the arc sine is only, the domain is from negative 1 to positive 1. So the computer knows what is going on. Okay, so that's it. Let's just go back and kind of review what we did. And you do this all these kinds of problems. You know, when you're looking for relative extrema. So when you want to know what the relative extrema are, you look for critical numbers. Critical numbers are when the first derivative is equal to 0. So we took the first derivative, we got that, and we solved for x algebraically. We got two solutions because when we took the square root, we got plus or minus. We got plus or minus the square root of 3 over 2. So then the question was, were these minimums or maximums? So we used a second derivative test. So we took this derivative, the 0 not only is to find the critical numbers, the first derivative expression is this. So when we took the second derivative, we used the chain rule here to get this part, and this went to 0. So this was the expression for the second derivative. We plugged in the two values of x, which were the critical numbers. We saw that the sign of this was negative, so it was concave down, which made it a maximum. Well, we plugged in positive the square root of 3 over 2. The numerator was positive, the denominator was positive, so the quotient was positive. That meant it was concave up, so minimum, and then we plotted it and saw that we were correct. And we also kind of tell that when we plug the numbers in, because when we evaluated the function at the negative answer, we got plus 0.685, and when we plugged in the second solution into the function, we came with negative. So obviously this has to be maximum, this has to be minimum, despite the relative values. And they were relative extrema, but they were also the extrema, because there was a limited domain on this. It was from negative 1 to positive 1. And so the endpoints were not higher or lower. So not only were they relative extrema, but they were absolute extrema as well. Okay, the last problem. Decided to throw a word problem in there. Actually, usually the word problems are easier once you figure out what's going on. So 89 says, an airplane flies at an altitude of 5 miles towards the point directly over an observer. Consider theta and x as shown in the figure. Write theta as a function of x. Okay, so a lot of these problems, we've done these before. It's kind of like a related rate problem. You want to create a right triangle and use right triangle geometry to help you out. So here's theta. Here's the opposite side, the adjacent side. So which function involves adjacent over opposite over adjacent, or adjacent over opposite? We'll use the tangent function. So we can relate it by the tangent of theta is equal to 5 divided by x, opposite over adjacent. So that's it. Now, that's the relationship. But they want theta as a function of x. So we take the inverse tangent. So we say theta is equal to the inverse tangent or arctangent of 5 over x. Or we could have done it, the cotangent of theta is equal to x over 5. So we could also say that theta is equal to the inverse cotangent of x over 5. Either way, we get the same answer. Okay, the speed of the plane is 400 miles per hour. Find d theta dt. Find d theta dt when x is equal to 10. So it's two choices, two questions. When x equals 10 and when x equals 3. So we have, and then speed is dx dt. Actually, that's not true. Yeah, dx dt. So speed relative to the ground is dx dt. So that's 4,000. So this is a related rate kind of problem, miles per hour. So what we're going to do is we're going to take the derivative of both sides with respect to t. So if you do that, you'll get d theta dt is equal to, okay, we're going to take the derivative with respect to t of the inverse tangent of 5 over x. So we have to use the chain rule. So we take the normal derivative and then we're going to multiply it by dx dt. So we go back to, page 374, look for the arctangent. And so it says the arctangent is u prime. Okay, so let's define u here. So u is equal to 5 over x. So u prime is equal to, well, this is equal to 5 times x to the minus 1 power. So you get negative 1 times 5 times x to the minus 2 power, which would be negative 5 divided by x squared. X goes to the denominator, becomes positive. So that's u prime. So the book says d dx of the arc tangent of u is equal to u prime over 1 plus u squared. So this is, I'm not using the chain rule, use substitution. I'm just going to use the formula here as an option. So once I've defined u as this, and I've got u prime, then, which is u prime of x basically. So this is the chain rule. So what you get, now we're taking the derivative with respect to t, so what happens is we get u prime, so we have negative 5 over x squared, that's u prime, divided by 1 plus u squared. So u is 5 over x squared. So I've got u prime over 1 plus u squared. And then I multiply by dx dt. That's the related rate situation. So that basically says that d theta dt is equal to negative 5 over x squared divided by 1 plus 5 over x, 1 squared times dx dt. Okay, so that wasn't a whole lot more information. But dx dt is 4,000 miles per hour, is that right? 4,000. I think it's cooking. Oh, it's 400 miles per hour. Okay, that sounds a little high. That sounds more reasonable. Otherwise, it was going supersonic. Okay, so it's 400 miles per hour. And we have two values of x, so we're going to evaluate this thing at two values. So we're going to have x equals 3, d theta dt is equal to minus 5 over 3 squared divided by 1 plus 5 thirds squared times 400 miles per hour. So what do we have? Let's see. if you want to, I'm going to do it on one calculation. So I'll have negative the quantity 5 divided by 3 squared. So that's my numerator. And I'm going to divide by the quantity 1 plus the quantity 5 divided by 3, quantity squared, close parentheses, times 400. And theta should be getting bigger. But actually, d theta dt is actually a negative number. Why is it negative? Because it's getting smaller. So x is getting smaller, so d theta, dx dt is getting small, is a negative number. Okay, so I need to multiply by negative 400. The reason I thought about that was because theta is getting bigger, so d theta t should be getting bigger. Okay, I did my usual problem. Forgot to use the negative sign instead of the minus sign. So I get 58.8 radians per hour, because this is miles per hour, and these are miles. Height was in miles, so the miles cancel out, and you get radians per hour. And the question is, what did they give the answer? Did they ask what the answer was? Because they could divide by 3600 to get radians per second. So let's see what they give the answer. Radians per hour. Okay, that's correct. And then when x equals 10, you get d theta dt is equal to minus 5 over 10 squared divided by 1 plus 10 divided by, 5 divided by 10. 5 divided by 10 squared times negative 400 miles per hour. So I'm just going to go back and change 3 to 10 in my calculator. 10 squared, and then, so let's see, I'm changing 3 to 10. Okay, I think I've got everything right. And I get 16. Is that right? Yeah, okay, that is right. Came out to be a nice even number, so I was wondering what I did wrong. Okay, so you get 10.0 radians per hour. Now, normally you'd think about seconds, so let's just divide that by 3,600 seconds per hour. It's pretty small, 0.004 radians per second. You can multiply by 180 divided by pi to get degrees, so you get 0.255 degrees per second. Okay, so that's it. And let's just review what we did here again. We drew a triangle, used the definition of a tangent to relate the tangent of theta to this variable x. We could also do a cotangent, would have worked out as well. Might have been easier to take the derivative there. So then we took the inverse tangent of this, and you get the inverse tangent of the tangent is theta, and you get the inverse tangent of 5 over x. You can do the same thing with the cosine. So then we said, okay, now we need to find d theta dt. Well, t is a separate variable for x and theta. So the right-hand side just becomes d theta dt, and then you have to use implicit differentiation on the right-hand side because the derivative is with respect to t and the variable is x. So when you do that, you do the normal derivative process where this is u and u prime is the derivative of that, which is negative 5 over x squared. So when you take the derivative of the inverse tangent, you use this expression. But we add the dx dt on the end because it's implicit. We plug in u prime here, we plug in u here, And we get that expression, and then to actually find the values, we just plug in x equals to 3 or 10, depending on which part of the problem. The speed is constant, negative 400 miles per hour, and you get the resulting d theta dt, which are in radians per hour. And you can convert them to radians per second by dividing by 3600, because it's 3600 seconds an hour, 60 seconds per minute, 60 minutes per hour. 60 times 60 is 3600, so you divide by 3600. And if you want to get the degrees, to convert from radians to degrees, you multiply by 180 divided by pi. So you get that answer.